Sarah was healthy. She loved being outdoors, hiking, and living an active life. Then, over what seemed like a relatively short period of time, everything changed. She developed high blood pressure, couldn't sleep, lost weight without trying, and began experiencing digestive problems, muscle pain, overwhelming fatigue, and brain fog. At first glance, they looked like separate problems, but what if they weren't? What if they were all connected? This is Sarah's story. So, what happened to Sarah? How does someone go from hiking through the woods, enjoying life, to suddenly dealing with high blood pressure, digestive problems, muscle pain, insomnia, brain fog, overwhelming fatigue, and losing weight without even trying? Those sound like a whole bunch of different problems, and honestly, that's exactly what Sarah thought. It's what her doctors thought. It's what almost anyone would think. What if they were seven clues pointing to the very same biological process? Our bodies don't read medical textbooks. Your gut doesn't wake up in the morning and say, "Today I'm doing digestion, so I'm staying out of whatever the brain is up to." The thyroid doesn't know it's supposed to stay in its lane. The immune system doesn't check in with cardiology before it does something. Everything is talking to everything else all day, every day. So instead of asking which symptom do we chase first, we asked a completely different question. What biological pattern could connect every one of these symptoms? That's when Sarah's story became a biology story. At first glance, Sarah's symptoms didn't seem to have much in common. High blood pressure, insomnia, digestive problems, muscle pain, fatigue, brain fog, and weight loss. They don't immediately point to a single diagnosis. In fact, most people, including many healthcare providers, would naturally assume they're dealing with several separate conditions. And that's one of the challenges in modern healthcare. We often organize symptoms by the organ that they affect. Blood pressure belongs to the heart, digestive problems belong to the gut, brain fog belongs to the brain, and muscle pain belongs to the muscles. But the body doesn't work in isolated compartments. Every cell is constantly communicating with every other system through hormones and nutrients, inflammatory signals, the nervous system, the immune system, and energy metabolism. When one underlying biological process begins to affect several of those systems at the same time, the result can be a collection of symptoms that appear completely unrelated. Could all of these symptoms be connected by the same underlying biology? That question became the starting point for Sarah's investigation. By themselves, Sarah's symptoms didn't tell us what was wrong. They simply told us that several systems in her body were struggling at the same time. The question was whether those systems were failing independently or whether something deeper was disrupting them all. This is where it's helpful to step back and think about how the body actually works. Our organs don't function in isolation. The brain communicates with the gut. The immune system influences the nervous system. Hormones affect metabolism, inflammation, energy production, and countless other processes. Every system is constantly exchanging information with every other system. And when an underlying biological process begins to disturb that communication, the effects can appear almost anywhere in the body. One person may notice fatigue first, another may develop digestive problems, someone else may experience brain fog, insomnia, or muscle pain. The symptoms may look unrelated, but they can all be different expressions of the same underlying biological disturbance. So instead of chasing each symptom individually, we asked a different question. What common biological process could explain all of them? That question would lead us in a very different direction than simply treating symptoms one by one. At this point, it would have been easy to focus on each symptom individually. High blood pressure could be treated one way, digestive problems another, insomnia another, brain fog another, but treating symptoms one by one doesn't necessarily explain why they appeared together in the first place. When several body systems begin struggling at roughly the same time, I start asking a different set of questions. Is something interfering with cellular energy? Is there chronic inflammation affecting multiple tissues? Could environmental exposures be disrupting normal physiology? Is the nervous system under constant stress? And rather than viewing each symptom as a separate disease, I began looking for a common thread that might explain the entire picture. And that's the difference between asking what diagnosis does this symptom fit and what biological process could connect all of these symptoms. For Sarah, that shift in perspective changed the entire direction of the investigation. So far, we've established Sarah was healthy. She developed multiple seemingly unrelated symptoms. The body is an interconnected system. We chose to follow the biology instead of chasing diagnoses. Once we decided to look beyond Sarah's diagnoses, the next step wasn't to guess, it was to gather evidence. Every biological process leaves clues. Sometimes they're found in routine blood work. Sometimes they're hidden in a person's history, their diet, lifestyle, environment. And sometimes they require more specialized testing. So rather than assuming we already knew the answer, we began asking what had changed in Sarah's life before her symptoms began. Were there environmental exposures that might be affecting her biology? Were there signs of chronic inflammation? Could her body's ability to produce energy be compromised? Were there hidden stressors placing an ongoing burden on multiple systems? Instead of focusing on one symptom at a time, we looked for patterns that connected them. And that's an important distinction. Patterns often reveal what individual symptoms cannot. And as we gathered more information, one particular pattern began standing out. Sarah underwent environmental testing, and one of the results immediately caught our attention. Her BPA level was extremely elevated. Now, that result didn't prove BPA was responsible for every symptom she was experiencing. A laboratory result is just one piece of evidence. It's not the entire story, but it did tell us something important. It confirmed that Sarah had been exposed to a significant amount of an environmental chemical known to interact with human biology. That finding fit with what we had already been seeing. Her symptoms involved multiple body systems, and BPA is one of the many chemicals that research suggests can influence multiple biological systems. So rather than giving us a final answer, the laboratory result gave us a new direction. It helped us to focus the investigation. And the next question became even more interesting. How could one environmental chemical potentially influence so many different parts of the body? The reason that BPA can affect more than one part of the body is that it does not act in only one place. BPA can interact with cellular signaling, particularly hormone-related signaling. Hormones help regulate metabolism, brain function, blood vessels, immune activity, energy production, and many other processes. So when a chemical interferes with those signals, the effects may appear in several systems at once. BPA has also been studied for its relationship with oxidative stress and inflammation. These processes can influence mitochondrial function, cellular energy production, vascular regulation, and nervous system activity. Now, this does not mean that BPA produces the same symptoms in every person. The biological response depends on the amount and timing of exposure, how long it continues, nutritional status, genetics, health history, and how effectively the body processes and eliminates the chemical. In Sarah's case, the elevated result helped us to understand why her symptoms might not fit neatly into one or two diagnostic boxes. The chemical exposure was not necessarily creating several separate problems. It may have been disturbing several connected biological pathways at the same time. And that raised the next question. Why was Sarah carrying such a high level in the first place? And was her body able to clear it effectively? At this point, we had more questions than answers. The elevated BPA level was an important clue, but it didn't explain how Sarah became ill. It simply told us there had been a significant exposure or that her body wasn't processing and eliminating BPA efficiently. So the next step was to step back and look at the entire timeline. What changed? Did something happen shortly before she became sick? Were there new environmental exposures? Had she traveled? Was there something about her work or daily environment that deserved a closer look? These questions matter because timing is often one of the most valuable clues in a complex case. A sudden decline suggests we should pay close attention to events that occurred just before symptoms began, while also considering whether there were longer-term factors that may have increased vulnerability over time. In Sarah's case, there were several clues. She had recently traveled. She worked closely with animals. At this stage, none of these clues proved what had happened, but together they continued to give us direction. By now you might be thinking, so was it the BPA? Maybe, maybe not. One of the biggest mistakes we can make is assuming that finding an abnormal test result means that we've solved the case. Biology rarely works that way. High BPA could be part of the story. It could have contributed to the problem. It could have made an existing problem worse. Or it could simply be evidence that Sarah's ability to process and eliminate chemicals had already become compromised. Those are very different possibilities. The truth is, laboratory tests don't tell stories. People do. A laboratory value only has meaning when it's interpreted alongside the person's history, symptoms, exposures, physical findings, and the biology that connects them. And that's why I don't chase numbers. I chase patterns. At first glance, Sarah's story seems like it's about one woman who became unexpectedly ill, but it really isn't. It's about how we think. Many of us are taught to ask, what disease does this person have? And that's an important question, but it's often not the first question. A better place to begin is asking, what changed in the biology? What disrupted the system? What reduced its resilience? What altered its ability to adapt? Those questions don't ignore diagnoses, they help explain them. Because before symptoms become diagnoses, before diagnoses become chronic disease, something in the biology has usually been changing for quite some time. And that's where I believe some of our greatest opportunities lie, not simply in naming the condition, but understanding the biology that allowed it to develop in the first place. So, in part two, we'll begin following those biological pathways and see how the clues in Sarah's story start fitting together. So, thank you for spending this time with me. I hope Sarah's story has demonstrated something important. Not that we should fear every chemical, and not that every illness has a simple explanation. Certainly not that every person follows the same path. What I hope you'll remember is that symptoms are often only the beginning of the story. Behind every symptom is biology, and behind every diagnosis is physiology. And behind every person is a unique history that deserves to be understood. And the more we understand how the body's systems communicate and adapt and repair and recover, the better questions we can ask and the more meaningful our answers become. So thank you again for joining me. I hope you'll continue with me in part two, where we'll begin exploring the biological pathways that may have shaped Sarah's story. Until then, stay curious and please hit that subscribe button. Bye for now.